Good morning, students. Welcome to the yet another lecture of Advanced Green Manufacturing System. Now what we need to do is we need to do how the calculations are done in this specific case. So now what I am going to do is I am going to show you how the calculations are done with these values for that particular thing. Okay. So we have seen previously what are the values of SST. Okay. So first let us calculate SST, sum of squares of total. Okay. So SST, as I said earlier, is sigma I equal to 1 to A, sigma j equal to 1 to B, sigma k is equal to 1 to n. Okay. So three values, y I j k square minus y dot 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 square divided by A times B times n, right. This is what we were talking about. So if you expand this, okay, this is equal to, so let me use big N is equal to A times B times n, which is 3 times 3 times 4. So that is equal to 36 in this particular case. Okay. So that is what we will be using as the denominator right here. Okay. So this will be equal to, when we compute this, it is 130 square. So where are these values coming from? These individual values, you square them, right. So those values will be 130 square plus 155 square plus, okay, the third value will be 74 square, 180 square, you square all those values, right. So plus 74 square plus all the way up to the last value in this regard is 60, this particular value, right. So plus 60 square, okay, you square all those values. This will be your, this whole thing translates to this term minus, what is your y dot dot dot? We know that we calculated it as 3799. So this becomes 3799 square divided by the bottom value is 36, which is your n. Okay. So you square all individual observations, sum them up, then minus these value. And when you do this, typically I use Microsoft Excel or somebody to set this up in such a way that it actually is easy for us to compute. This values comes to 77,646.97. Okay. So these are, this is the total of what we call a sum of squares of total that we compute in that particular area. Okay. Then the, now compute, okay, main effects. Okay. So sum of squares of A, or what we call as in this case A is material. Okay. So you can also call it as sum of squares of material also, that is also fine, or you can call that as A and use sum of squares of A. That equation, remember, 1 over B or Bn multiplied then summation of I is equal to 1 to A y I dot dot square minus y dot 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 square over A B n. This was our equation. So if you plug in the values, it will come to, so the y dot dots are 998, 130, 1300, 1501, right. So what we are doing here is 1 divided by the value of B is, as we see, B is 3. So A is equal to 3, B is equal to 3, n is equal to 4. Okay. So this will be 3 times 4, okay, multiplied by what it is you have the values, which is these 998, 1300, 1501. So 998 square plus 1300 square plus 1501 square. Okay. This is the first term minus the same term 3799 whole square divided by 36. Okay. So when you do this computation and calculate, you will actually get a value of 10,683.72. Okay. So this is the sum of squares of A, the first factor, or the material. Okay. So the second, so we are done with A. For the thing is machine speed, factor B. So we can call it as okay, SS of B, sum of squares of B, which is equal to sum of squares of speed, okay, is equal to 1 over equal to as AN summation of j is equal to 1 to b. Now, in this case the summation is on j, the factor j, and we told us y dot j dot square minus y dot 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 square over a b n. Okay. So, what we are going to do in this particular case is we are going to use the same values. A is 3, n is 4, and then it's a summation. So, where do we get the y dot j dot? So, if you look into this, this is your y dot j dot. 1738, 1291, 770, these three values are used in this case. So, then what we do is we put them 1738 square plus 1291 square plus 770 square, okay. All these values are squared up minus 3799 whole square divided by 36. The same values are being used in this particular case, and you get the values to be 39118.72. Okay. The most of the time is like, remember this, using Excel like spreadsheet sheets make these computations easy. Okay. So, once you have an Excel sheet, then doing all these manual calculations, otherwise you would require a lot of calculator time to get these values calculated, and you can make errors. Okay. And minimize errors also, minimize or reduce errors, reduce calculator errors. Okay. So, once you are done with the main effects and the sum of squares of total, now the next thing for us to do, the third part of the calculation we have to do is the what we call as the sum of squares of interaction, okay, and error. Those are the sum of squares we need to calculate now. So, now what we are going to do is we are going to now do the sum of squares. Now, let us calculate. Now, let us calculate. Now, calculate the interaction effect. Interaction effects. Okay. So, the interaction effects are calculated as I told you earlier, SS of interaction, okay, or sum of squares of AB, both of them is calculated by the equation 1 over n, okay. N is the number of replicates. Remember, A was equal to be 3, B is equal to be 3, n is equal to be 4, okay. That is how we calculated it, 1 over n, okay. And then sigma I is equal to 1 to A, sigma j is equal to 1 to b, both this one, and what we had was yij dot square minus y dot dot square over a b n. This was one of the factors, okay, minus sum of squares of a minus sum of squares of b, okay. So, this whole thing is your sum of squares of subtotal. Okay. So, what you do is you calculate the sum of squares of subtotal in this regard, and then from there you subtract out these two values. So, your SS subtotal, okay, is equal to, now we calculate it this way, it is basically 1 over 4, okay. Then what are the values that you are going to use? You are going to use these green circled values 539, 229, 230, 623, 479, that kind of values. Okay. So, we use the mass 539 square plus 229 square. Okay. So, you can see that 229 square, 230 square all the way to 342 square, right, at the end of the day, plus all the way to 342 square. Okay. This is the first part of it, then minus y dot dot square is same thing, we already calculated 3799 square divided by 36, okay, and this value, okay, we get it one particular value, right. From there what happens is, so this is how when you compute this is your subtotal is. From this what you do is SS interaction is this particular value SS subtotal minus what we used to got here previously was the A4 was 10,682, that was 39,118. So, what we do is we do it as 10,683.72, that is your SSA, minus 39,118.72, and when you do this calculation we get a value close to 9613.78. Okay. So, if SS interaction is less than 0, what does it mean? Okay. This is a question that you need to think about. Okay. If this value comes to be negative, okay, if this value is not non-positive value, what is it? Is it something important, or is it something that you made a calculation mistake? You need to find that. Okay. This is something called as a homework. Okay. You need to find out. So, now we calculate the SS interaction. Then the last one is lastly calculate the sum of squares of error. Okay. So, how do you calculate SSE in this regard? So, remember SSE is calculated as SST total minus SSA minus SSB minus SSAB. Okay. So, you are now subtracting all the other error things. Okay. So, where did you calculate your sum of squares of total? This is your total. From here you subtract this value, and the last value. So, that is equal to, if you write that equation, it will come to 77,646.97. From that you remove the SS of A. SS of A is 10,683. So, that is minus 10,683.72. From that again subtract 39,118.72. So, that is 39,118.72. Okay. Then you subtract this last term that you had, which is 9613.78. Okay. You did go through all the subtractions, then what happens is you get the error, the remaining error of it, which is 18,230.75. Okay. So, there might be some round off values that you might actually see. I just rounded off to 2 digits, and some of this might also, Excel might have done some rounding off also. So, now we have what we call as the entire values. So, if you go back, you have your totals here. Okay. This is your SST, you have the total value, you have your SS of A, you have your SS of B, okay, and then you have your SS of AB, and you have what you call as your SS of error. Okay. With all these values put together, what we can do is, now with these calculations are being done, we can create what we call as our ANOVA table. Okay. So, the next step is to create what we call as the analysis of variance table. Right. So, the analysis of variance table or the ANOVA table, as we seen earlier, is built in a particular fashion. So, remember for ANOVA table. So, the table has a very different heading in this regard. We have source of variation. Okay. Then we have what you call as sum of squares. Remember the columns. Then we have the degrees of freedom. Okay. Then we have the mean squares. Okay. F value and P value. Okay. So, the and then the source of variation was factor A. So, in this case what we know is that if you go back to the table, the factors are material type and machine speeds. So, we go back and we say it as material type. Okay. This is your A. Then the machine speed, speed, this is your B, right? Then interaction, this is AB, right? And then what we have is error, right? And then we have is last one is total. So this is our ANOVA table, and let me write this interaction as AB right here. So I don't want to get into the sum of squares things. So the material type A, the sum of squares, where do we get those values? These values were all calculated. So we just now plug in these values, okay, into the table. So the sum of squares in this case was 10,683.72. For this particular machine speed, it was 39,118.72. And interaction, we calculated it as, if you think about it, was 9,613. So we put that value 9613.78, and then the total value was put in. If you remember, it was put in as 77,646. Okay, so the total is 77,646.97, and the last value we calculated was error, which was 18,000. Okay, so that value goes here, 18,230.75. So all the sum of squares goes into this particular column, and then the degrees of freedom that need to go here. So this is like degrees of freedom is A minus 1, and we know A, the value of A is equal to 3, B is equal to 3, N is equal to 4. So A minus 1 is 3 minus 1, so that value is 2. The degrees of freedom here is B minus 1, which is again 2, right? This value is what is the interaction degrees of freedom? It is AB, okay, and minus A minus 1 times B minus 1. So this value is A minus 1 times B minus 1 as 2 times 2. That value comes to be 4. Then what's the total error degrees of freedom? This is ABN minus 1. So that is 36 minus 1. So this will be 35. So how do I calculate the error degrees of freedom? So error degrees of freedom is equal to error DOF is equal to total DOF minus DOF of A minus DOF of B minus DOF of AB, which is equal to 35 minus 4 minus 2 minus 2. Okay. So if you do that, then you get the value to be 27. So that degrees of freedom is 27 right here. There is an equation also, ABN minus 1, which you can use if you want to, but I would rather do it this particular fashion, right? So once we have the degrees of freedom, then the next one we need to calculate is what is called as the mean squares. So mean squares is sum of SSA by DOF of A, okay, which is equal to what we write here is 10683.72 divided by 2. Okay. So that value gives us what we call, in this particular case, it is equal to 5341.86. Okay. Second one value that we calculate same way is 39118.72 divided by 2, and that value you get it to be 19559.36. This one will be 9613.78 divided by 4, and that value comes out to be 2403.44. Okay, and this value comes, the last value comes to be 18230 divided 0.75 divided by 27, and I get that value to be 675.21, right? Now the F value in this particular case is calculated by, the way to calculate this is the equation here is MSA divided by MSE, the error. Okay, so what we are doing is 5341.86 divided by 675.21. Okay, this value in our case, so this is this mean squares divided by the error mean square. You get the value to be 7.91. That is the F value. In this case, it is calculated as 19559.36 divided by 675.21, and that value is calculated to be 28.97. The third one that we calculate is 2403.44 divided by 675.21, which will be equal to 3.56. Okay. So, the three values for the A, B, we calculate the mean squares of errors. Okay. Then the p values are calculated from the chi-square distribution. So, we use the F table to find p values. Okay. And otherwise you can also use it Excel to find the p values. I will give you the p values in this regard. It is 0.002. In this case the p value is equal to 0.0001, and here it is 0.0186. Okay. So, this p value is the same as that of, okay. So, what we say is that compare, okay, p values with level of significance, which is alpha. Okay. So, the level of significance alpha is what we need to compare, and if you say the alpha is 0.05, then all these factors are significantly important for us. Okay. So, that is the way then you compute. So, in this case we can say that at 95% confidence, all three are significant because p value is less than alpha, which is 0.05. Okay. So, then we say we need to look into all these three. So, our model will have at 95% interval, our model Y will have the A, the B and AB combined. The effects of A, B and AB will be used at 95% confidence. So, I hope that this actually helps you guys to understand how the calculations are made and how the ANOVA is created and how the decisions are made based on this. So, now what we will do is we will now just quickly look into some of the optimization algorithms quickly, and then finally we will conclude the lecture towards the end as a group discussion of how do we optimize things. Thank you very much for your patient listening.